Hello guys, today we are going to make realistic spreading fire. In this tutorial, we are going to use the infection method for spreading fire and render with mantra. You can see the behavior of fire. For fire emission, we are going to use fire as a geometry light. As you can see, we are getting fire breaking, and some nice fire streaks. Let's dive into Houdini. For the model, I have used Mixamo.com. Take a geo node and dive inside it. Take an agent node. In the input method, select FBX. From the FBX file, select your FBX geometry. Now you can see out geo is not animated, it is in his rest pose. To make it animated, we need to change the current clip to Mixamo.com. To make the animation fit perfectly in frame range, I'm going to use Retime node. Please note that my timeline starts from 10:01. Adjust yours according to your timeline. Take a convert node. As you can see, before convert, our geo was in packed agent, but after converting, our geo is back to its normal mesh. Now it's time to set up infection mechanics. Take a time shift node and freeze the first frame. Then add a scatter node. Change the force total count to 10,000. Take a wrangle node and set the infection value to 0. Take a blast node. We are going to make an emission point. Means from this point our fire will spread. For this specific animation, I'm going to use the head and both the palm as emission points. Take a sphere node and reduce the scale. Take a copy to the point node and connect the second input to blast, and we need to copy the sphere, so connect the sphere to the first input. Take a group node. Connect the first input to scatter and the second input to copy to point. We are going to isolate the points from scatter that are present inside the sphere that we have copied. Change the group type to points and turn off base group and turn on keep in bounding reason. Now in bounding type, select bounding object. Now take a blast node and delete the group 1. Toggle on delete non-selected. Copy the attribute wrangle and this time make the infected attribute value to 1. Merge both the wrangles. As you can see, we have so many unwanted attributes. Let's delete this, or simply we can remove all attributes and scatter itself. Take a solver node, connect it to merge, and dive inside. Take a wrangle node and connect the first input to the previous frame, and in the second input of wrangle connect object merge input 1. Now we are going to write simple vex expressions. Press the plus icon to add the parameters that we created in Vex. Set both the value to 10. What we have done here? Basically, first we set the all points color to black. Then I wrote the if statement. What if statement does? The if statement is a decision-making statement that guides a program or code to make decisions based on specified criteria. Here the criteria are infection values. If it's 0, then it's going to evaluate the given parameters. We are going to use the nearPoints function. NearPoint use 4 inputs. The first is the input that we want to look at. In our case, we are going to connect it to the previous frame. Second, we want to look at the position. The third and fourth are the spare parameters. Now I'm going to feed this in a loop using the if statement. Now I have created 2 integer data, that is pt and found. Nowhere is our if statement. If the given statement comes true, then it's going to assign the given attributes to the point. So our statement is, if the value of the point attribute named infection is 1 in the current loop, then it's going to set the infection attribute to 1 and color to red color on the nearby point. Since we are using a nearPoint function, let's see this using Sketch. Let's assume this is our point. The red color point is our infection point. So what does the nearPoint function do? It will look at st closet point in the geometry from the given value. That is the parameter that we created. Max distance and points, it will go to look at 10 nearby points. For the distance, it uses the xyz dist function. So the orange arrow is our closet point. Now it comes to the for each loop. It's going to make every point infected which is nearby to infected point. So our one loop is over. In the next frame solver calculates again, but now our previous frame has more infected points. Now, these infected points will look to their closest points and going to infect more points. This is going to loop again and again in every frame until all the point gets infected. I hope this is clear to you. Let me know in the comments section. Now we have set the infection to static mesh. But we need animated geometry. Let's do this by using point deform. Connect the solver output to the first input of point deform. In the second input connect out static geo. That is timeshift node. And in the third input connect our animated geo. As you can see, we are getting some issues. To fix this, reduce the maximum point to 1. Now we are going to set up some fuel attributes. Take a timeshift node and freeze it to the first frame. Take a Pyro source node, connect first input to point deform and second input to timeshift. Reduce the particle scale to 1.5. In the attribute section, select temperature and turn the scale value down to 0. Delete all the groups using the group delete node. Add a rest position node. Now we need to delete the points which have infection value 1. To do this, take a blast node and write it infection equals 1 without any space. It won't work until you switch the group type to point, since infection is a point attribute. Toggle on delete non-selected. Now we are going to animate the temperature using a fit function. Instead of applying directly to temperature, I'm going to make a temporary attribute named fire. Take a wrangle node and write an expression. That is going to animate the fire value from 1.5 to 2.5 till frame 1025. Now set the temperature attribute as fire and burn to 1. Take a volume rasterize attribute and add burn and temperature in the attribute section. First, reduce the particle scale to 0.05, then reduce the voxel size to 0.007. Add a null. Now we need to make a better collision shape. Let's do that. Take a trail node and set the result type to compute velocity. Take a VDB from polygon and set the voxel size to 0.0015. Down below on surface attribute, click on the plus icon. In attribute, select point.v. And in vector type, select displacement velocity acceleration. Cache this VDB collision to disk. Add nulls. Take a DOP network and dive into it. Add a Pyro spar solver. In the first input, add smoke object sparse. Take a volume source. In the SOP path, points out our outburn null. Let's change a few of the parameters. Delete the density field and velocity since we don't want that. Change the operation to pull in temperature. Increase the acceleration strength to 50. Reduce the scale to 0.5. Add a new field. In the source volume, write burn. In the target field, write flame. Change the operation to maximum and reduce the scale to 0.5. This process is just for visualization. Reduce the voxel size to 0.01. As you can see, we are not getting fire in starting frame. To fix this, we need to turn on enlarge field to contain sources. Take a merge node and connect it to second input of the solver. Add a gas wind node. In wind scale, writes this expression. Let's preview this. Add a gas vortex confinement. In Pyro Solver, reduce the timescale to 0.8. Change the advection reflection to a single project. Reduce the reference temperature to 2500. Reduce the buoyancy scale to 0.15. In the flame section, change the flame lifespan to 0.3. In the shape section, change the shredding amount to 15. In the shredding field, add temperature instead of density. Increase the max octave to 4. Change the base block size to 0.1. Change the pulse length to 0.1. Turn on turbulence and keep it to the default value. In the Advanced tab, increase the max substeps to 3. In the Resizing tab, increase the padding to 0.15. Take a DOP import node and import our fire. Add a convert VDB node. In the Convert to tab section, change it to VDB. Take a VDB vector merge to merge our vector volume. Add a Pyro bake volume. Let's adjust the look of fire. Decrease the voxel size to 0.007. Take a volume wrangle node and write this vex. Basically, we make the temperature value to 0, if the length of velocity goes less than 1. Now let's add our collision geometry. Take a static object inside the DOP network. Turn on Use Deforming Geometry. Import our geo. In the Collision tab, switch the collision detection to Use Volume Collision. In the mode, select Volume Sample, and in Division method switch to By Size. Import the VDB collision and proxy volume. Reduce the sign sweep threshold to 1. And max sign sweep count also to 1. Let's cache our simulation. Let's set up render. We are going to use a mantra for this. We don't need to make a fire shader because the Pyro bake volume is going to assign a shader by default. In mantra ROP, change the render engine to physically based rendering and turn on motion blur. In the Limit tab, increase the volume limit to 2. In Sampling tab, change the min ray sample to 10 and the max ray sample to 20. Increase the pixel sample to 8 by 8. Take a light node and change the type to geometry. Switch to Area Light Option tab. Turn off the Normalize Light Intensity. Turn off Self Shadow. Take a Geo node and dive inside it. Take an object merge and import our Pyro bake volume. Now in Geometry Light Import, our newly create Geo node. Increase the exposure to 3. As you can see, we are getting so much noise. To decrease this, increase the sampling quality to 32 in Geometry Light. You are done. Thank you guys for watching. See you in the next tutorial. Make sure to hit the like and subscribe button. Share it with your friends and help me to reach 1,000 subscribers.